So we have opened the meeting, but we will wait a minute before we start to let everybody be able to join.
Recording has started, so no worries about that. Should I admit all?
4 people in the lobby.
I've just done it, guys. I'm on it.
I see still people are joining, but given the fact that we have a lot to cover, I would like to start the meeting now. So with no further ado, my name is Tony, and good morning, good afternoon to everybody, and welcome to our webinar. Yeah, people are still joining, and a lot of you too. So we're very honored and excited about having so many people joining us today to learn about how agentic AI and digital workers really will change the way we think about well construction and how we think about our industry in general going forward. But before we start, there are some housekeeping items. We really would like your questions because this is a very new era for all of us. We will also answer them at the end, so please use the Q&A function in Teams. It's on the top menu. And then we will get to that at the end. Also, the webinar is recorded, and we will provide the recorded webinar as well as the presentation used for all of you after this. Before we kind of get going, I just wanted to introduce this era we are in at the moment. Call it Agentic AI era, which is what I do and many people do. Like the PC era and internet era before it, I think this promises again to transform well construction. But also, I think differently, because I'm old enough to know, I've been around since the PC started. In many ways, this is going to build on the previous two. So stand on top of it to deliver on some of the stuff that we were not able to deliver on previously. In addition, something new is going to come out of this, or already has come out of this, and that's in the areas of automation or autonomous drilling, and also in data management, which we will show here today. So there's no reason to take my word for it. There's no doubt that agentic AI is here, and it has compelling value. And there are more and more applications, or if you like, not applications, but AI agents or digital workers around delivering value from day one. On a personal note, I have to say that when we started this work building AI agents 2+ years ago now, I had no idea how quickly and how profound and how massive and groundbreaking this would be. How we thought was just another new technology ended up being a new era. Not only the R&D behind it, but also the sheer number of applications or agents coming out of it and how far we've come already. So today we will introduce you to IDA. We will talk about what sets IDA apart. We will demo we will talk about some use cases and demonstrate some use cases for you, and then we will go through her anatomy, what makes all of this possible, and at the end we will do Q&A with today's speakers. So with no further ado, I'll let the speakers, starting with G, I guess, take over.
Thank you, Tony. Good morning and good afternoon, everyone. My name is G. I'm a Chief Technology Officer here at eDrilling. Let me today introduce Ida to you. Ida is our new digital drilling engineer powered by Agentic AI. Ida works tirelessly 24/7. She helps to deal with drilling tasks. Whether it's routine tasks or critical decision making, Ida is always there to support. So Ida is a valuable team member and a companion to help ambitious team to achieve more. So what does Ida do? In general, Ida reasons, makes decisions, and take actions to pursue goals. She's an experienced engineer who has been through as many wells as possible, as much as we provide. She finds the optimal combination of controls to reach to TD in the most efficient and safe way. She can also automate the complex, repetitive tasks, allowing your team to focus on more strategic activities. You can deploy in the autopilot mode, or in a copilot mode, and it is the customer's privilege to choose level of each. She will take care of routine tasks and decision makings while being a reliable companion for the entire drilling crew. Meanwhile, I understand that it's easy to be confused and think of Ida as another AI application, but Ida is a digital worker and isn't just another AI app. First of all, she's a learning machine instead of a static database. So unlike systems that store and recall data, Ida returns knowledge, allowing her to adapt and evolve. Think of her as a supervisor. She studied extensively to provide guidance and insights, even though without memorize every detail. Also, Ida acts as a user of apps, autonomously pursuing complex goals we set for her. She uses tools like modeling and simulation software, especially for drilling, and predictive AI software, and dynamically adjusts her approaches based on new information provided. Last but not least, Ida knows not just data, but also the physics behind drilling. Ida learns from the physics behind drilling through training in the simulation environment and also in the interaction with digital twins in real time. This differentiates Ida from most data-driven AI applications we have seen so far. So here we list 5 use cases as examples. For example, first of all, Ida optimized parameters. So when deployed, Ida controls critical parameters like tripping speed, rate of penetration, weight on bit, RPM, and more to ensure optimal performance while safeguarding the well. This will be global optimization thanks to reinforcement learning and dynamic modeling to verify the results. Ida also prevent incidents. By that, I mean Ida predicts anomalies and early symptoms of hazards and diagnoses potential issues and take actions to prevent those risks from happening so that to prevent downtime and reduce the risks. Ida is also a subject matter expert. She learned from a large domain knowledge library and knows the stuff about petroleum industry, especially oil and gas and drilling. Another important value or a key use case is that Ida help you to manage the data. Ida autonomously retrieves, validates, and organizes data in predefined formats and saving your teams hours or days of manual work. Last but not least, Ida supports all kinds of wells. With a diverse group of wells for training, Ida supports all kinds of wells. Whatever is a factory well, offshore well, or unconventional well, Ida adapts to every scenario, making her a versatile partner for all kinds of drilling challenges. Now I think you have a good, clear understanding of Ida's architecture and the methodology. Let's move to the most exciting part, the demo part, to see the real benefits working with Ida. Next, I would like to introduce my colleague Rezi to talk about the first demo.
Thank you for the introduction, G. Good morning and good afternoon, everyone. My name is Rezi, an AI scientist at eDrilling. Today, I would like to start the demo part of the showcase of Ida by showing one of Ida's key use cases that have been presented before, which is optimizing drilling parameters to improve efficiency and maintain safety. The first example that we've prepared for today demonstrates that IDA actually can successfully drill a well, which in this case is a vertical section, a relatively simple drilling operation designed to test its or her core drilling capabilities. And the objective was pretty straightforward, which is to drill as fast as possible while staying within the safety boundaries. This plot in the slide compares IDA's performance in blue with how the well was historically drilled, represented by the red lines, showing parameters that IDA and also the historical team can control, which is the block speed, rotational speed, and the mud flow rate. The plot shows that IDA not only completed the well by reaching the TD successfully, but also achieved the objective of reducing the operational time when compared to the historical operation. While the previous slide demonstrated that IDA can drill a well faster than the historical well, this plot in this slide highlights how IDA achieved this improved efficiency without compromising safety. In this plot, key operational parameters such as the standpipe pressure, the weight on bit, and other parameters are shown to remain within the defined safety limits as indicated by the black dashed line. This example in particular demonstrates that IDA not only meets its objective of faster and more efficient drilling, but also achieves the objective responsibly, ensuring that all parameters managed safely and effectively throughout the drilling operation. But we also prepared a second example where IDA demonstrates her ability to drill in a more complex section, which is the deviated section of a well, representing a more complex and challenging operation when we compare it to the vertical section compared to in the first example. Deviated drilling introduces unique difficulties, with mainly the challenges is to maintain effective hole cleaning to reduce the risk of hazards such as the stuck pipe, which is a critical factor to ensure safe and efficient operation. While the overall objective of drilling efficiently remains the same as the first example, this example highlights how IDA can adapt its control strategy to suit better or requirements of the deviated section of a well. The plots in this slide reveal that IDA achieved a drilling speed and time which is comparable or close to the historical performance in red, but with slight adjustment in some of the controls to address the requirement for the deviated trajectory. And in this slide, we have the 3D visualization providing a closer look at the operation, highlighting the challenges of drilling in the deviated section, while also making sure that IDA on the left used the controls that she proposes in the previous slide when compared to the team of engineers on the right-hand side of the plot or of the video. By applying the control strategies shown earlier in the previous slide, IDA reduced the cutting concentration, which is the parameter that we use to represent the hole cleaning compared to the engineer's controls. This is visually represented in the bottom side of the video by the lighter or yellower color for IDA, indicating lower cutting concentration, while the engineer's controls show a darker and redder color. This particular example demonstrates that IDA not only matched the performance of experienced engineers or team of engineers in terms of the drilling efficiency, but also improved the hole cleaning in a complex deviated section of a well. Together, both examples that we've prepared today demonstrate that IDA not only just capable of drilling efficiently, but also adaptable to diverse challenges, which in this case is the vertical and the deviated section of a well, all while maintaining safety and operational control. And with that, I'll now hand it over to my colleague, Tong, to showcase another exciting use case of IDA.
Thank you, Rishi. My name is Tong. I'm working in drilling as an AI scientist. I'm very happy to present to you how IDA can handle data. So here, sitting in the middle of the image is the drilling engineer, Yusuf. Yusuf wants to find some useful information from the data, and he wants to explore the data, or he wants to generate a configuration file as the input for software. But the thing is, he's faced with loads of documents and different databases and files, and he has to read through all these files and go through all the databases. And at one moment, he was thinking, what if I got an autonomous assistant to help me in a conversational way, just give me the answer that I want? As shown in this video, Yusuf just wants this system to be as simple as that he could just type some questions here and get some precise answers, no matter it's general knowledge or data-specific questions. For example, generating a configuration file or trajectory file for a software for further use. And then someone comes to Yusuf saying that, okay, you can use ChatGPT then. But for Yusuf, this is not the option. Why? Because the data situation in his company is very complex. The first pain point is that his company has a very big data lake, including all kinds of different data types like XML, CSV, PDF, HTML, all these different types, and they are stored either locally on a server or on a cloud. So this makes it much more complex. Another pain point is that they don't want to share their data. This is very important. So they don't want to open it to the public, which means ChatGPT is not a good option. Here comes IDA. Wait a minute. Here comes IDA as a solution to help yourself to resolve this question and problems. So in general, IDA has two inputs: the domain knowledge, which includes the knowledge from petroleum and drilling industry in general, and also internal data within a company's firewall. So IDA take those two inputs and leveraging the power of large language modeling and knowledge base and other techniques to help yourself to generate answers if he wants to do a knowledge search or some data management. But one thing to notice here that for the internal data from a company, IDA doesn't store any data from it. IDA, you can just plug in your data source to IDA. Just treat IDA as a working machine. And next, I'm going to demonstrate some use cases that IDA work on this direction. The first one is IDA as the subject matter expert with the knowledge search function. Here you can say a very specific example that's Yusuf is asking, how do you determine the optimal mud width for given information, pressure, and fracture gradient? And this is a very general knowledge within the drilling industry, and IDA is capable of giving a very precise answer with some data sources for reference. The second example is what is the methodology behind well guide for real-time diagnostics and optimization? So here, well guide is a very internal knowledge within our e-drilling company, and IDA get to understand it very well and return a very precise answer, which means IDA is capable of understanding the internal data well. And another two use cases is about data management, IDA as a data parser. So here on this slide, we see two panels. On the left panel shows a question, can you summarize the information of well F2 in the table? So this is a very internal data within eDrealing's firewall. And IDA can successfully understand, retrieve, and give a summarization of this very specific data. If you ask ChatGPT, he or she will have no answer about it, but IDA will. And on the right panel shows a question posting, asking IDA to generate a trajectory file using a specific template and using some specific data as the sources. And IDA successfully returns this configuration file in JSON, and which Yusuf can use it and download it for the specific use for software. So all those examples shows that IDA is capable of understanding both the general knowledge and also the domain knowledge within the company. And I hope this is clear. If you have some questions, just throw it to us and we'll answer it later. And next, I'm going to hand over the speech to my colleague Jie again.
Thank you, Tom. That was really exciting, especially the user. I would have problems every day with dealing with data and using the software more efficiently. Actually, I have been dreaming of having such a powerful companion for years. Meanwhile, I know there might be some skeptics that, especially for those who haven't know much about or used much of agentic AI, like questions how to make sure that the AI-powered digital workers like Ida are trustworthy and do not go wrong. Trust is the cornerstone of success, respective AI adoption at scale, requiring transparency, reliability, alignment, and privacy. We have a systematic design to build trust, including the fundamental design as shown here using a hybrid approach, which means that we are trying to marry physics with AI to achieve precision and trust. Here, physics mainly refers to the physics-based technology for drilling, like dynamic modeling, dynamic simulation, digital twins. By integrating those with agentic AI, IDA learns from both data and physical principles. It means that IDA is not simply learning from the historical data representing how we drill wells. And that would probably end up to be an average engineer. But we want more than that. With the models, especially the calibrated real-time models, IDA can try as many possibilities as needed to determine the best solution, like creating a multi-universe to try every possibility and find the best one so that she can learn from really the best solution. This hybrid approach ensures that her decisions are not only optimal, but also grounded into the reality of drilling operations. It's this combination of AI and physics that builds trust in her recommendation, actions, and outcomes. Finally, let's take a look at the IDA's anatomy to make sense what makes those things possible for IDA. IDA is designed to interact seamlessly with various users, drillers, drilling engineers, supervisors, and decision makers. At her core, as shown in the right block, IDA combines natural language processing with multiple interactions in the future to engage with users seamlessly. First of all, as the left small block shows, she has multi-agent architecture, meaning that there is a team of agents focusing on different tasks while IDA is managing the team to achieve the goal. For each specific task, a well-defined reinforcement learning agent, for example, is assigned to seek the objectives we set, concerning mainly safety and efficiency, for example, a drilling agent, as Resi demonstrated, or a tripping agent. Moreover, she is built upon the latest and greatest large language models and used launching agentic RAG, retrieval augmented generation, to retrieve relevant information quickly and accurately. The foundations on the bottom are the available tools to IDA, like we mentioned, including dynamic modeling, dynamic simulation, and digital twins developed and verified by the industry for decades. They are available as microservices to be used by IDA efficiently and autonomously. Though currently using mainly e-drilling tools, as we mentioned, those three types, external tools will be easily extended and to empower IDA as she needs. So on the left bottom corner is one more important thing about data protection. As you know, data protection and compliance are non-negotiable. Leaders in this industry must prioritize security to scale AI confidentially in a fast-evolving regulatory landscape. So on the left bottom is the IDA storage part, which is isolated from the main IDA or the core of IDA. This part is isolated because IDA doesn't store any data, as Tom mentioned, from the customer side, but only asks for access to part of the internal data when permission is granted. She learns, parses, and organizes those data and feedback to the users. This part of data integration is deployed only locally within the firewalls to make sure that the internal and the private data from every customer is well protected. So I would go back to Tony as to summarize the webinar and the QAs.
Yeah, so a lot of great stuff. To summarize, IDA is an AI drilling agent. And like human drilling engineers or drilling superintendents or drillers, she finds and executes the most efficient and safe way to TD. She does it every time, all the time, and she does it on every well, and she doesn't even need a break. She's available in autopilot mode, which for some is autonomous drilling, and in co-pilot mode. and as your company desires, any mode between the two. She's also resolving our decades-long, I would say, data universe value dilemma by unifying and interconnecting all the data needed for drilling operation. It's been a problem forever. Finally, because, or by virtue, I would say, of her unique competence level and experience, she will be the ultimate companion, like G was alluding to anyone on your drilling team. We have, well, it's time for questions, I guess. We still have some minutes left for questions. Okay, so let's check out the Q&A. So first question. Oh, it's a hard one. It's a good and important question, sorry. How are you planning to control the agents so they don't wander off to places where they should not be? Anyone? Team Ida?
I think I can take that one for Ida, or Ida is answering by me. It's really a good and important question. That's the first one of the first challenges we consider. So Ida is designed with a comprehensive control systems that ensures its behavior to remain aligned with operational goals, safety requirements, and engineering constraints. Our approach actually integrates domain-specific knowledge, as mentioned in the demo, and also physics-based modeling, as mentioned many times, and advanced AI technology to establish a robust system of checks and balances. This hybrid approach or hybrid methodology not only leverages the adaptability and optimization capability of AI, but also incorporates the reliability and predictability of physics-based constraints. Together, all those technology, we ensure that the agent or IDA can autonomously make decisions while staying focusing within defined operational boundaries. That's the only thing we need to, or that's the one of the most important thing we need to make sure while using IDA.
I just want to say to everybody, thanks for all the questions. There are way too many questions to answer in the next 2 minutes, but we will get back to you, all of you. It's a second question, though. It's similar, but I think it's very important. Again, how are you planning to control the agents so that they don't find up stuff that are not correct and can be dangerous?
I can take that one too. I think if I understand that question correctly, I think it's more about the generative AI part, because I think most of us have used tools like ChatGPT, where ChatGPT could possibly create something out of nowhere. But that's what we want to prevent or avoid while creating IDA. So to ensure the accuracy and the reliability of IDA, especially IDA's decision, is very critical, especially in high-risk drilling operations like what we do every day. IDA is equipped with a robust mechanism to prevent it from generating or relying on incorrect or unsafe information. This involves integrating validated domain-specific knowledge, as we have IDA domain knowledge library, and also cross-verifying decisions with physics-based models. That's the best we could have today, and that has been used and validated by the industry. And also employing human oversight for critical tasks. We have a human-in-the-loop system built in IDA system. When it's concerns to some or triggers some high risks, human beings will be, or domain experts will be called in to take control, to supervise IDA, to verify the strategies. So by combining all those strategies, we minimize the risk of agent producing false or dangerous output. Of course, you know, the AI are accelerating so fast, and we will keep ourselves up to date so that we take advantage of the latest and greatest AI technologies to ensure safety and accuracy while using IDA.
We're running out of time. I'll answer. There's a question that many of you have asked, and that is how to get a hold of IDA. And that was a slide that I had prepared, and it came in the wrong order. So sorry about that. But we do have a measured approach to deploying IDA in operations globally. It has to do with building trust. We think that's of utmost importance to do. So she's available for internships and she's available for graduate programs and the like. If for those interested, please contact us and request it. Ida is picky and she's ambitious, so we will get back to you on that. So and for all the other questions, we will get back to you later. So for now, I would say thank you to the presenters. Thank you for everybody joining, and have a great day and evening.
Thank you.
Bye for now.